Hello everyone. So today we are going to discuss on the topic eigenvectors and eigenvalues. Let me share my screen. 1 second. Okay. So this topic is from the IB level, grade DP 12, 11 and 12 basically in matrices, but definitely in other curriculums you do have this topic as well. Now when we talk about eigenvalues and eigenvectors, one thing we need to keep in mind that this is related to matrices where a matrix is given to you. For example, let's just start by understanding how it is sorted straight away, okay? So let us take a matrix example. I'll say A is equal to 5, 4, 3, and 1. Okay. Now, this is a matrix, and you have been asked to find the eigenvalue and eigenvector of it. Okay. So the first thing what we have to do, we need to find the eigenvalue because that's the first thing we need to know. It's basically eigenvalue is the lambda value, which we have to find it out. Before we move forward to find the lambda value, we need to find the characteristic polynomial. Okay, so what is characteristic polynomial? So basically it's the lambda function, that is, you can say lambda into identity matrix minus A, and the whole matrix, whatever you get after matrix, we need to find the determinant of that. Okay, let's just proceed one by one and we'll understand how to proceed further. So the first thing we need to find, as I said, we need to find this equation. We need to do that's lambda identity matrix. I'm going to put it 1, 0, 0, 1 minus A is your 5, 4, 3, 1. Okay. And then I'll just write here that we have to find its determinant. I'm going to multiply lambda into the identity matrix. That's lambda 0, 0, lambda. Okay. And I'll have to put a minus sign again. Then 5, 4, 3, and 1. Okay. And then again, I'll write here determinant that I have to find the determinant of it. Similarly, it's just basic subtraction of matrices. Okay. So I'm going to write lambda minus 5. 0 minus 4 is directly I can write as minus 4. Lambda, then over here 0 minus 3 will give you straight away minus 3. 1 second. Yeah, minus 3. And I'm going to write here lambda minus 1. Again, this is the matrix and then determinant. Now, one more thing you need to remember, what was the formula of determinant? Now, determinant formula, like if it's A determinant like this, you need to write AD minus BC. Okay, that's the formula for determinant. Similarly, we are going to do for this matrix. That is lambda minus 5 into lambda minus 1 minus 4 into minus 3. Okay, so once we need to solve it, we need to simply multiply how we multiply the two brackets of algebraic expressions. Okay, so for example, lambda into lambda, that is your lambda square, lambda into minus 1, that's minus lambda, then minus 5 into lambda, that's minus 5 lambda, and minus 5 into minus 1 will give you plus 5. And here you will write a minus sign as it is. Minus 4 into minus 4 will definitely give you a plus 12. So I'm going to write here plus 12. I'll just shorten the equation, lambda square minus 6 lambda, and it's going to be minus 7. So this becomes your quadratic equation. This is the characteristic polynomial equation which we are supposed to find. Now, from this, we will find the factors of it. Okay, so if we find the factors of it, we are going to get the two brackets. That is lambda minus 7 and lambda plus 1. Okay, which hence come to us a point that lambda value is lambda is equal to 7 and lambda is equal to minus 1. Now, these two values are considered as the eigenvalues. Okay, this is how you got the eigenvalues. So how you got the eigenvalues? You just put the equation. First, you find the determinant bracket, lambda into identity matrix minus A. You got that quadratic equation. You found the factors. And once you have found the factors, directly you put that answer as lambda is equal to, that's your eigenvalues. Now we are going to use these eigenvalues to find and get the eigenvector correspondingly. Okay. For example, if this is lambda is equal to 7, we are going to use the same equation, that is lambda into identity matrix minus A. But the whole thing, then we are going to write x and y is equal to 0. That will come at the end. So I'm going to write here lambda. Identity matrix is 1, 0, 0, 1 minus A is your 5, 4, 3, 1. Okay. And here I will write x and y is equal to 0 and 0 over here. This is the equation I'm supposed to form. Okay. Now, instead of this lambda, because we know already one value of lambda 7, so we will write here 7. And I'm supposed to solve this. Okay. So I'm just simply going to multiply 7 into the matrix. That is 7007 minus 5431 x and y as it is, and then of course 0 and 0 as it is. Okay. Next, we do a normal subtraction. Once we do a normal subtraction, we come to a number that is 2 minus 4 minus 3 and 6. Okay. And then I'm going to write here x and y is equal to 0 and 0. And I'm going to write this in an equation form. So I'm going to write this equation form. I'm going to take the first numbers like 2x minus 4y is equal to 0. This is my first equation. The second equation is minus 3x plus 6y is equal to 0. This is the second equation. I'm going to take any one of the equation such as 2x is equal to 4y. Definitely x is equal to 2y, right? And then I'm going to write in a vector form, that is x coefficient, excuse me, x coefficient will be over here, that's 1. Y coefficient will be here, that's 2. Okay, that's how you get eigenvector. Excuse me. So basically, from that particular eigenvalue, we got the eigenvector. Okay, so when the lambda was 7, we got the vector as 2 and 1. Okay, that's your value. Similarly, the second case is lambda is equal to minus 1. Again, the same thing we are going to repeat. We are going to do lambda into
It's
identity
20
matrix
hours.
minus a. The whole thing I'm going to get right here, x and y is equal to 0 and 0. Okay, what I did earlier. So what I'm going to do here, I'll write here minus 1, 1001 minus my a is what? 5431. I'm going to write here x and y is equal to 0 and 0, okay? And minus 1, 0, 0, minus 1, then minus simple subtraction, how I did earlier. Nothing new in this. It's just the way you write it step by step. You will never make a mistake. It's very important for you to write each step. Yes, few basic steps you can skip definitely, but steps are really important. If you do everything mentally, there are few things. First of all, a lot of mistakes can happen. Second, the examiner might not like it that you are missing the steps. The steps does have marks. So it's always better to write the steps in case you do some silly mistake at the end. So you are definitely going to get some marks. Okay. So if we subtract this further, we are going to get minus 6, minus 4, minus 3, minus 2. X and y here is equal to 0 and 0. Okay. And the same thing I'm going to do is to write the equation. That is minus 6x minus 4y is equal to 0. That's my first equation. Then minus 3x minus 2y is equal to 0. That's my second equation. Okay. I'm going to take up any of the equations. Let's just take up the first one. That is minus 6x is equal to 4y. Or I can write minus 3x is equal to 2y. And as I said earlier, the x coefficient will be here. Okay, that's minus 3. Y coefficient will be here. That's 2. Okay. Okay, 1 second. It just turned into a circle. Okay, 2. Okay, so this is your eigenvector. Okay, hence if I'll just conclude it, A was basically 5431. You got eigenvalues as 7 and 1 minus 1, that were lambda values, right? And eigenvector as you got 2 and 1 when the lambda was 7 and the other one was 2 and minus 3. Okay, so just a quick recap. Once you get a matrix, you need to find the characteristic polynomial. That's the quadratic equation. And how you get a quadratic equation? You find the determinant of the equation. The equation is lambda into identity matrix minus A. You get the quadratic equation, you get the factors. From the factors, those are the eigenvalues. And that you're going to substitute again in the equation of lambda into identity matrix minus A. And then at the end, x and y you're going to put, you're going to write an equation. X coefficient will be below, y coefficient will be above, and that's how you get the eigenvector. I hope this is clear. I will bring up some more topics in the next video. Thank you. Take care. Bye-bye.